This is lesson 13.3, and in this lesson we will learn how to factor using the greatest common factor, also known as the GCF. Okay, before we start learning how to factor using the GCF, let's talk about factors and some other vocabulary. So previous to this, you've learned about factors as a noun. So the factors of a number, so if we say the factors of 12, so the factors of 12 are the numbers that go into 12 evenly, so that'd be 1, 2, 3, 4, 6, and 12. All of those numbers are factors of 12. If we talk about the factors of 15, then that's 1, 3, 5, and 15. If we talk about the factors of 7, we only have 1 and 7. Now, because that happens, this is called a prime number because the only factors are 1 and itself. So we've talked about factors before as a noun. And in algebra, what we're going to do is we start also talking about factor as a verb. And so when we talk about factoring in algebra, we are talking about breaking down a product into its two parts. And so when we talk about we have a product, and in this case it's going to be a polynomial, we're going to find out what do we multiply to get that polynomial. So we'll be working backwards from what we did before. In the last lesson, you learned how to multiply polynomials together. So if you had like x plus 2 times x minus 3, and you learned how to multiply that using distributive property and so on. What we're going to do this time is we're going to start with a polynomial, and we're going to see how do you end up with the factors. What do you multiply to get that? So that's what we're going to do today. Now, to talk about the greatest common factor, and this is always the first thing you learn with factoring, make sure that you understand that these words are here for a reason. So we've talked about what a factor is, but the word greatest and the word common is also part of that phrase. So when we determine the greatest common factor, we have to find the one that is the greatest. So for example, if I had 12 and 18 and I'm trying to find the greatest common factor, I can list all of the factors of 12 and 18. And then I can look for the one that they have in common that is the greatest. So it's not going to be 18. That might be the greatest factor, but it's not in common. And so the one that they have in common that's the greatest would be 6. 3 is a common factor, but it's not the greatest one. Now there's other ways to do this, and this is actually going to help us a lot in what we're doing right now. And so another way to do this is to break 12 down into its prime factorization. So if I say 12 is 2 times 2 times 3, and then break 18 down into its prime factorization, so it's 2 times 3 times 3, then what I can do is I can look for whatever they have in common. So they have 2 in common and they have 3 in common. And so my greatest common factor will be 2 times 3, which is 6. And so we're going to actually use that strategy to help us because we're going to have some variables, and this will help make that a lot easier. We're going to start with a couple that you probably already know, but we're going to use the strategy that we just did. I just actually did 12 and 18, so I'm not going to do that one again. But that greatest common factor was 6. So let's look at 45 and 50. So what you do is you take 45 and let's break it down to prime factors. I know it's 9 times 5, so 3 times 3 times 5. And then 50 is 5 times 10, so 5 times 2 times 5. Now it is nice if you put them in order from least to greatest, but sometimes that's just not how you think of it. So if I look for what they have in common, they actually only have this one thing in common. So that one's pretty easy. It's just 5. You don't have to multiply anything together. Okay, look at number 3. Now we've got some variables in the mix. So we're going to take 12m squared and we're going to break this down. So like we did before when we were trying to simplify our expressions, we're going to break that down. So 2 times 2 times 3 and then times m times m. And then 9m, I'm going to break that down to 3 times 3 times m. Now look for what they have in common. They have 3 in common. They also have m in common. So my greatest common factor is 3 times m, or 3m. So we get the greatest by taking all of them and multiplying them. We get common because we've only taken the ones that they had in common and we're only using factors. So let's try this with 24x squared y and 8xy. If you want to pause the video and try this and just see if you get the right greatest common factor. Okay, what you should have done is you should have listed out 24. I can say it's 4 times 6. So 2 times 2 is 4, and then times 6, and then x times x and y. And then for 8xy, it's 2 times 2 times 2 times x times y. So looking at what they have in common, they have 2, they have another 2, they have an x, and they have a y. So my greatest common factor will be 2 times 2 times x times y, or 4xy. So that's the greatest common factor between 24x squared y and 8xy. Okay, a couple more. So 5, 36n squared m to the third, and 6 n to the third m. So especially if you didn't get the last one right, you definitely need to try this one on your own. But try this one on your own and see if you get the right answer, and then come back and check. Okay, I've listed all of the factors, breaking it down into prime factorization for each of these numbers. And so you go and you look for what do they have in common. And so I see that they have 2, 3, n, m. And so my greatest common factor, I'm going to multiply all of those together. And so I'm going to have 6 n to the second m. And so that would be my greatest common factor. You can also write that as 6m n squared. That's actually better because it's in alphabetical order. I'm not going to worry about that, and you don't have to either, but that is something that we will eventually take a look at. Okay, try number 6. Okay, I've listed my factors, and so I'm looking for what do they have in common. And so this strategy of writing all the factors out and then circling what they have in common, this one is like kind of a no-fail method. This is going to help you make sure that you're not missing anything. And missing something is really the number one reason why these problems go wrong for people. So you don't want to miss anything here. So that's going to be my GCF. All right, now we're going to look at factoring the polynomial using the GCF. So using the GCF is our number one factoring method. We're going to learn other factoring methods, but GCF is always the first one you check for. So the first thing you want to do is you want to look at your terms in your polynomial and see if they have a GCF. So I have two terms in my polynomial. I have 21x and I have 14. And so if I find the GCF of those, I'm going to say 3 times 7 times x, and this is 2 times 7. What do they have in common? They have 7 in common. So my GCF is 14. Now that's not, or sorry, not 14, 7. Now that's not the answer to the question because I didn't say what is the GCF. I said factor using the GCF. So what you do with that is you're going to take the 7 and you're going to put it right here. And I'm going to say 7 times what is going to give me this product. And so I'm looking for 7 times something is going to give me the 21x minus 14. Now, as you get more practice doing this, this will become a lot easier to do. But for right now, a really good strategy is to, for your first term, you're going to take what's left over that was not common, and then look at the sign right there, and then take that. And what you have is you have this set of polynomials that if you multiply it together, you get 21x minus 14. You can check your work here because you can check it and make sure that it works. Yep, that gives me the product that I'm supposed to get. So I know that my answer is right. And so that's one thing you want to do when you're factoring is always make sure you factored it correctly by making sure that it works. So this right here is your answer to the problem. So instead of having the product, we're having what makes the product. Okay, let's try number 8. Again, you look at the two terms individually. Like I said, once you get practice with this, you won't maybe need to do all of these steps, but you want to make sure that you've got this right and that you're not missing a step or not getting the GCF. If you're only getting a CF or just a common factor, that's not the same thing. And so you have to get the greatest common factor. So like I said, doing this is kind of a fail-safe way to do it. So my greatest common factor here is 8. And so I'm going to put that outside my parentheses. And then if I look at what do I have to multiply, I have to multiply 3m. Okay, so 8 times 3m is 24m. But then you look at this and you're like, well, nothing's left here. Something is left there. Okay, you can't just have 8 times 3m and that's it, because then that would just be 24m. Well, what about the plus 8? So what you do is you're going to say sign is plus and then 1. Try that back together. So if I do that, that's going to be 24m plus 8. So that's what you want to do. So make sure that you get the right product, and if you have nothing left in your list of factors, you always have a 1. Okay, so this would be your answer right here. Okay, go ahead and try number 9 on your own and see if you can get the right GCF and then also if you can correctly factor it. Okay, the correct GCF is going to be your 3 times 3 times x, so 9x, and then you're going to multiply that by something, and so you look to see what you have left. So 2 times x to the third. And then down here again, we don't have anything left, so we have a 1, so I'm going to say plus 1. And then check, it's going to give you 18x to the fourth plus 9x, and that's what I started out with, so I know that it's right, and so that's how you factor. So the great thing about factoring is you always can know if you're right because you have to multiply it back together to get what you started with. Okay, we've got a few more examples to do with factoring. This one is a trinomial, and so what that means is when you factor out the GCF, you're going to have to multiply it by a polynomial so that you get a trinomial in the end. So if you think about how that's going to work, you kind of have an idea of what that's going to look like. So let's start with finding our GCF. So 5k to the third and 8k to the second, and then k. The only thing they have in common is a k. So k is my GCF. So what am I going to multiply? The first one is going to be 5k to the second. And then you look at the sign. You have to get the signs right. And then I'm going to have 8k, and then look at your sign, and then I'm going to have 1. Check it by multiplying it together and making sure that if you multiply that monomial times a trinomial, you do get a trinomial. So that looks appropriate. Okay, let's go ahead and practice. We've got 4 more to practice, or 6 more to practice on this notes. And so I'm going to have you just pause the video, and I want you to do 11 and 12, and then come back and see if you did it right. And think of what questions you have and make sure that those get answered, and then we'll continue on. Yeah, number 11, when you went to find the GCF, did you notice that there was no GCF? And so you might have wondered, what do you do with that? Well, remember the example that I showed you a minute ago when I showed you the one with 7, and I said that the only factors of 7 are 1 and itself, and so we call that prime. So what we have here in this polynomial, there are no common factors, and so the only way you can factor it is by saying 1 times this polynomial. So we're not going to say 1 times it, we're just going to say that it's prime because there's nothing you can multiply to get that. There's no GCF, so there's nothing you can multiply. That just is the polynomial, cannot be factored. So once in a while you'll get something that cannot be factored. I will caution you that before you say something is prime or that it can't be factored, you need to make sure that you've gone through all of the possibilities. Have you checked the GCF? Later, when we do other forms of factoring, have you checked all of the other possibilities? Because sometimes it might look like it can't be factored, but maybe you just missed something. For number 12, I've listed each of the terms and written out all of their factors. So prime factorization on all of them. Now, when you have 3 terms and you are looking for the greatest common factor, it has to be common with all 3 of the terms, not just with 2 of them. So it cannot be a greatest common factor if it's only in common with 2 of your terms. So I'm looking for what we have in common between all 3 of these. And so I see that they all have a 2 in common. I notice that these 2 have another 2 in common, but since the top one does not, then that's not going to be a greatest common factor. So as far as the numbers, the numerals, the 2 and the 3, that's all that they have in common. There's nothing else that they have in common with all 3 of them. Now, if I look at the variables, I can see that they have an x in common, and these 2 also have another x in common, but not the last one, and so that's it. So my greatest common factor is going to be 2x. So I'm going to be multiplying that by a trinomial, because if you think about it, I'm going to have to multiply it by a trinomial in order to get a trinomial right there. So when I look to see what I'm going to multiply by, the first one is I'm going to take 3 times x, so 3x squared. Check it. This is going to be 6x to the third power. That's what I need it to be, so it looks good. Okay, the next one is going to be, oh, don't forget to check your sign right there, minus, and then 2 times x. And then if you check that, that's going to be 4x to the second power, negative, so that looks good. And then check your sign, and then the last one is 2 times 2, and that's 4. And so you can check this whole thing and make sure, like, that's going to be 6x to the third power minus 4x to the second power plus 8x. Your signs have to be correct. All of the numbers have to be correct. Your exponents have to be correct. If anything is wrong, then that means you factored it wrong. And technically, then the whole thing is wrong. If you have factored it correctly with the GCF, then if you look inside your parentheses, they should have nothing left in common. So there's nothing in common with all three of those. If like they all had an x, then you did not get the greatest common factor because they all still have an x in common. So you would have to like check and make sure, but this would be your factorization for that. Okay, let's try 13 and 14. These are just binomials, so go ahead and try both of those and then come back and see if you did it right. On 13, you'll notice that the first term is negative 10y squared, and that's something we haven't seen before. And so when you write that down, the negative 10y squared, I'm going to put a negative 1 times 2 times 5, and that gives me in the negative 10. But then we have this other issue that's going to come up in just a second, and I'll show you it in a second. But this one does kind of create a little bit of a different problem. So looking at my greatest common factor, whoops, I see that I have 5 and I have y, and that's all. So I'm going to have 5y. And then if I look at what I have to multiply by, it's going to be negative 1 times 2, so that's negative 2 times y. Check your sign, minus, and then 7. So when I check that, it does come out to be negative 10y to the second power minus 35y. So that's good. That's what I wanted. Now, when we factor, one thing that we kind of steer away from in math is we kind of don't like that negative sign to be there. It's just kind of an awkward thing, and it's not that it's wrong, it's just awkward. And so one thing you can do to work with that is when you factored the 35, since you had this negative 1 right there, but 35 is positive, you can do negative 1 times negative 1. So it's still positive, but then what you have is you have a negative 1 as a GCF. And what that does is it makes it so that the GCF is negative 5y, but then this would be positive and this would be positive. So check that. So when we're factoring, if you have a leading coefficient, meaning the first coefficient is negative, it is common practice and best practice to pull that negative out with it, and then the signs are going to be changing inside your parentheses. So if you want to pause and go back to number 14, because you're going to have that same situation, see if you can factor it so that you do not have a negative sign right there on that first term in your parentheses. Okay, if you factored number 14 according to what I just said, best practice, then this is what it's going to look like. If you factored it by what we had done before, then you would have positive 3np, and then you would have negative n squared plus 2p. And so while this is not wrong, it's not the best way to do it. So I don't like to do it that way. I won't be doing it that way. You need to get in the practice of not doing it that way. So if you see that negative as a leading coefficient, then get used to pulling that out. So just going over how we would do that again. So negative 3n to the third power p, and then 6np squared. What I'm going to do is I'm going to write negative 1 times 3 times n, and then times p. And then because I have this negative 1, and I notice like, oh, hey, I've got a negative 1 right there, I'm going to make this one, since it's positive, I'm going to do negative 1 times negative 1. Now it's positive. And then I'll do the rest. So 2 times 3 times n times p times p. So then I'm going to look for common factors. So I have a negative 1, I have n, and p. So negative n, oh, I forgot the 3. Negative 3np times, and then we're going to look and see what we have left. We have n times n. Now, the next one you have to be careful of, because you're not going to just take this sign, because if you did a plus right there, then when you multiply it back together, you're going to get a negative, and then that doesn't work. So when you pull the negative out, you want to make sure that you're saying this is going to be a negative 2p. And so what's going to happen is right here, you're going to write minus 2p, like that. So then when you multiply it back together, you've got negative 3n to the third p, and then negative times negative is positive 6np squared. Okay, last two examples. 15, we are going to see that with the leading coefficient is negative, so keep in mind what we just talked about. And then do number 16, and then you'll be ready to go. I wrote out my factors, and I did put the negative ones in there, so if you didn't do that, I want you to stop and look at what I did and how are you going to fix what you have. And I'm doing that so that I can get that negative 1 pulled out. So I'm going to say negative 1 is part of the GCF. Okay, now as far as the 3's and the 2's, they don't have anything in common between all three terms. So then I'm going to go to C's. They have C. They don't have any other C's because the first one doesn't, it only has one C. So then I look at D's, and they have that one, And then they have another one. So my GCF is -1, but I'm not going to write the 1. I'm just going to write negative. And then C D to the second power. You could write 1. It's just not really something that we do. And so then what's left is 3D. And then this is -2 C to the second D. And then this is -4 C. And then you want to check, for sure check these ones. So we're going to multiply that. So I'm going to have -3 C D to the third plus 2 C to the third D to the third plus 4 C to the second D to the second. And check, is that what I should have? You know what it should come out to be because that's what you were factoring. It looks like I do have one sign that's wrong. So that's why we check it. Now, if I go back and look at why it's wrong, if I look right here, this is a negative. And so when I broke this down and I said -1 times -1, that gave me a +2. So if you want to look at it like that, then maybe when we broke that down, we should have just said -1 times 2, and it would have gotten -2. It's really easy to fix. You just notice that it's wrong, and you just change the sign, and then you can go through it, change that, and then it comes out right, because then we've got -C times +2, and so that's going to be negative. So you just want to check your signs in the end and make sure that they're right. That's really important, because if you get one sign wrong, then the whole polynomial is different. So you want to make sure that it comes out to be the correct one. And so in all of this, remember what your answer is. Okay, your answer in this problem is the factored part. This is your answer. This is where you checked it down here. That's where you just check to make sure. Now, is it required that you check? No. Is it recommended? Yes, highly. So you don't want to do a test or a quiz and not check your work. Okay, the last one, your GCF on this one is going to be 10AB. That's what they have in common. And what you're multiplying by is 2AB plus 3. And so that's how you did that. So if you look at your GCF and you write it out, you're going to have 2 times 2 times 5 times A times A times B times B. And then 30AB is 2 times 3 times 5, so 6 times 5, and then A times B. And so what do they have in common? They have that, so that's 10AB times, and then you look, what do they have left? 2 times AB, look at your sign, 3. Okay, you should now be ready to do your assignment for 13.3.